half d tau E inverse x dot square minus m square E, and then you take the variation of this, so you write 1/2 d tau, and then you have those three terms again, so minus e to the power minus 2 x dot square into delta E minus m square into delta E, and plus E inverse into twice x dot into delta x dot. So if you like put mu here, then you put mu here, or vice versa here or here, as you like. Okay. So, or let me just leave it. This is the dot product of this. This is much simpler, right? The dot product of this. But am I making some mistake? No, it's delta x dot. Okay. So you vary just this 2x dot into delta x dot. And now we have this. So here you can, and this is also one equation of motion, m square E square. So from here it's very easy. For delta E, I would write this in my this expression. Okay. And delta E does not worry me too much because it's a total derivative. Okay. d by dt of xi into E. Right. So at two places I have delta E. I can connect these terms and they are time total derivative terms. I would like to see, can I also reduce this into a total derivative term? Then my job is done. Okay. So I first try to see this x dot into, so you simply take this equation and you differentiate. And you can do this job. This is, so equation of motion. This would mean m square E square m square is minus x dot square. So you get 2e into delta E into m square is minus 2x dot into delta x dot. And so either I can this is wait 2 minus 2x dot into d by dt of x dot minus 2x dot into x double dot. Simple. Minus 2, I differentiate it on both the sides, minus 2x dot into x double dot. Okay. And this, and then I need to put it back into this here. This is, I can, let me simplify it separately. So there is a term E inverse, 2E inverse, 1/2 into 2 into E inverse into x dot into delta x dot. This is gone. E inverse x dot into delta tau of x mu or x, and this is E inverse x dot into del tau of delta x, and delta x I have it there, which I can put here. So this is second term, okay? This is E inverse x dot into delta of that delta x. So xi into x dot, xi into x dot. This is E inverse x dot, E inverse x dot into xi x double dot plus xi dot x dot. Okay, so you can simplify. This is x dot delta x dot. Could I collect all the terms here, and then we could see. So we are talking about delta S P A. This is equal to 1/2 d tau into this bracket, where the bracket means m square d upon d tau of E into xi minus m square d upon d tau of xi into E. These two terms I get for these two terms involving delta E. So these two terms, they are from here in delta E, and this term would separately give me so d tau, this plus I would have m square minus m square. In fact, I would have just minus 2m square into this is another term. This term, actually, if you can just making use of these things, this term would reduce simply to this term. Okay, this term would reduce to this, and therefore what we have is in this action, this we have 1/2 d tau times some coefficients. Okay, maybe precisely these coefficients are 1/2 this minus 2m square, because these two terms might cancel each other, and this would be only minus 2m square. So that means when you integrate this d over d tau, this would be gone. This would be just xi into E over the time boundary, and xi is a parameter, but E is a field. This field E would vanish at the time boundary, infinite time boundary. So this would delta S, this would vanish again. But if you find any difficulty, it's a very, very simple algebra, although I did not follow step by step in this, but the basic idea is you vary this, put the values of delta E from here, and put delta, here it appears as delta x dot, you convert it into delta x like that, and then you put this value. So just make use of these two here, and this variation of delta S become 0. It would be actually the total time derivative of xi into E, and this integration and differentiation would go away, just xi into E would be left to be determined at the boundary time boundary, and the field E vanishes there. So this would be, could I remove things? Yes? Lambert? Yes? Okay, thank you.